morning students, welcome to Maths online class. Next chapter is Introduction to Euclid's Geometry. The word geometry that comes from two Greek words that are geo meaning the earth and metrion meaning to measure. And you know that Euclid, he is called father of geometry or founder of geometry. Geometry that is originated from the need for a measuring land. In ancient civilization, many people worked on this, but the developments which was done by that people were passed from one generation to another generation, either orally or by palm leaf messages or by any other temporary ways. But Euclid, he is a teacher of mathematics at Alexandria in Egypt. He collected all the known work of geometry which was done by that people and collected it in his famous treatise. He arranged that it in his famous treatise that is called Elements, and he divided these elements into 13 chapters. Each is called a book, and that books influence the whole world's understanding of geometry for the generations to come. Okay. And in this chapter, we shall discuss Euclid's approach to geometry and try to link it with the present day geometry. Okay, thank you. Next is Euclid's definitions, axioms and postulates. In the book 1 of elements, Euclid listed 23 definitions and some definitions you are given in your textbook and that are like this. First one, a point has no part. Okay, suppose you draw one point that has no part, so it is the dimensionless one. Okay, point is dimensionless because it has no part. And second one, a line is a breadthless length. Suppose you draw line, it is a breadthless length, means it has no breadth, it has only length. That you can see. Actually this is a line is very thin, so line is a what? That is a breadthless length. It has no breadth, it has only length. Next, the ends of a line are points. If you see ends of this line, they are what? They are points. Okay. And next, a straight line lies. A straight line is a line which lies evenly. Evenly means uniformly. Okay. Uniformly with the water, with the points on itself. You know that on a straight line you have infinitely many points like this. You have infinitely many points on a line. So here how they given definition for a straight line. Straight line means that is a line which lies evenly with the points on itself. Okay, that line lies with the water with the points on itself. That straight line is a line which lies evenly, uniformly with the points on itself, and that is the fourth one. And next, fifth one, a surface is that which has a length and a breadth only. Okay, a surface is that which has a length and a breadth, means a surface is a two-dimensional one, and a surface is that which has a length and breadth. That is the fifth one. And next, the sixth one, the edges of a surface are lines. For example, if you see board, that is a surface. If you see edges of that board, that are what? You can see edge of that board. Top edge is a line, and that left side edge, that is a line, and this bottom edge that is also line. So surface, the edges of a surface are what? Are lines. Then a plane surface is a surface which lies evenly with the straight lines on itself. For example, you take this as one plane surface. Plane surface means what? That is a surface. How that surface is on the surface you have many straight lines like this. Okay, You have infinitely many straight lines. So here they given a definition of a plane surface like this. A plane surface is a surface which lies evenly with the straight lines on itself. Evenly means uniformly with the water with the straight lines on itself. Okay. So that is the definition for a plane surface in Euclid's first book of elements. And here by observing these definitions you can see that to define one term of geometry you need to define several other terms. Okay. To define one term you have to define several other terms, means to understand this term you need to explain that term by using several other terms, right. So to understand these terms you have to use several other terms. Some more terms you have to use to explain these terms. So while defining one term you need to explain several other terms, and to define that terms you need to define some more terms. So in the process of defining you may get a long chain of definitions like this without an end. Okay, this process continues. So you may get a long chain of definitions like that without an end. For such reasons mathematicians agree to leave some terms of geometry as undefined terms, and that undefined terms are a point and a line and a plane. So these three terms are agreed by mathematicians as undefined terms in geometry. Okay, thank you. Euclid he assumed certain properties that are not to be proved. These assumptions are actually obvious universal truths, and he divided that assumptions into two types that are postulates and axioms. And postulates are what? Postulates are assumptions which were made by Euclid and that are accepted without any proof. Okay, without any proof you can accept that properties assumptions and are applicable only to geometry. So postulates are what? That are assumptions which are accepted without any proof, without any question, and are applicable to geometry only. Okay, and axioms are what? Axioms are also properties which were assumed by Euclid, that are assumptions accepted without any proof, without any question, and that are applicable to all branches of mathematics. So what is the difference between postulates and axioms? Both are what? Both are assumptions, properties assumed by Euclid, but postulates that are applicable to what? Applicable to geometry only, but axioms that are applicable to all branches of mathematics. And for these assumptions you are not having any proof, you can accept that assumptions without any question, without any proof. Okay, thank you. Next you have some axioms of Euclid's geometry. Okay, some Euclid's axioms are first one, things which are equal to the same thing are equal to one another. I will explain you this first axiom through one example. Okay, we take things which are equal to the same thing, and you can see that two things which you taken, they are equal to one another. Okay, I will take a line AB which is equal to the line XY which is of length 2 centimeter, for example. Okay, I taken a line AB which is equal to the line XY of length 2 centimeter, and I will take one more line CD which is also equal to the same line XY, okay, that is of 2 centimeter. So AB, that line segment is equal to XY, means AB is 2 centimeter, and we take a line segment CD which is also equal to XY, means this line segment is also of length 2 centimeter. So now what you can see, these two lines are equal to one another, right? So this is about axiom 1, that is, if you take two things, two line segments here which are equal to the same thing, which are equal to the same line segment XY we taken. So then you can see that these two line segments are equal to one another. So that is the axiom 1. Things which are equal to the same thing are equal to one another. Here we taken two line segments AB and CD, two line segments AB and CD which are equal to the same line segment XY. So now you can see that these two line segments AB and CD are equal to one another. Okay, so that is for axiom 1. Next, axiom 2. If equals are added to equals, then the wholes are equal. Okay, so that for that also I'll take a same example, line example. I'll take two equal line segments. I'll take AB and CD line segments. Both are equal to 10 centimeter. Okay. So now what you have to do is you have to add equals. If equals are added to equals, then the wholes are equals. That you have to show. Okay. For this two line segments, I'll add equal line segment 2 centimeter. Okay, I'll add a line segment of length 2 centimeter to both. Okay, so we are adding what now? We are adding a line segment of a length how much? 2 centimeter. Here also I'll add same length line segment 2 centimeter. Okay, so what we done here, AB and CD, they are already equal. Okay, these are equal, AB and CD are equal. To that equals, what we done here, we added equals 2 centimeter, 2 centimeter. So then what is a whole straight line? This whole straight line is of length how much? 12 centimeter, right? And here also I'll name this end point as X, and here end point I'll take as a Y. So now whole line segment AX is of length how much? 12 centimeter, and here we added a 2 centimeter to this 10 centimeter line segment. Now the whole line segment CY is of length how much? That is of length 12 centimeter. Okay, 12 centimeter. So what we can say, if equals are added to equals, then the wholes are also equal. You can see both the line segments are of a same length, 12 centimeter, 12 centimeter. Okay, we added equals 2 centimeter line segments, we added two equals, that is two line segments of length 10 centimeter. We added equals 2 centimeter to equals 10 centimeter. Then the wholes are 12 centimeter in both. Okay, 12 centimeter, 12 centimeter. Then the wholes are equal. Okay, we added 2 centimeter line segments to equal line segments 10 centimeter. Then the whole line segments are equal to one another. Both are of length 12 centimeter. That is the second axiom. And next, if equals are subtracted from equals, then the remainders are equal. Now you take AX. Okay, AX is of length how much? Just now we saw that AX is of length 12 centimeter. Okay, this much is 10, and for that we added 2 centimeter. So then whole line segment is of length what? This is 10 centimeter, and this is 2 centimeter. And here 10 centimeter, this one CD, and dy is of length 2 centimeter. Now what you have to do is you have to subtract equals from equals. Okay, then the remainders are equal, that you have to show. Now whole line segment is of length 12 centimeter. Here AX of length 12 centimeter, and here CY line segment is of length 12 centimeter. Now we subtract equals from these two equals. Okay, both are equals. Why? Because both the line segments are equal to 12 centimeter. So from these equals, if you subtract equals, then what we get, we see. Okay, I'll subtract equals from these two. Equal, I'll subtract 2 centimeter. I'll erase a line segment of length 2 centimeter here also. Okay, so then what are the reminders? Reminders are 10 centimeter, here also 10 centimeter. So if you subtract equals from equals, then what reminders you got, that reminders are equal to one another, that is this third axiom. Okay, and next fourth one is things which coincide with one another are equal to one another. Things which coincide with one another are equal to one another. Coincide means suppose you keep one thing on another. If that two things exactly match in shape and size, then we say that two things coincide each other. So if things coincide each other, then they are equal to one another. For example, suppose you take a equilateral triangle ABC. Equilateral triangle means all sides are equal. I'll take one equilateral triangle with the 2 centimeter side. Okay, and I'll take one more equilateral triangle with the same length, and that triangle is XYZ, which is a equilateral triangle with the sides are equal to 2 centimeter. Now if you keep this triangle XYZ on this triangle ABC, equilateral triangle ABC, then these two figures exactly match in shape and size. Okay, so we can say that these two things coincide each other. So if things coincide each other, then they are equal to one another, we can say. These two things coincide each other, because if you keep a ABC triangle on this or this on this, then they exactly match in shape and size. But if you take like this triangle ABC, we take a equilateral triangle. Okay, easy to understand. If you take a equilateral triangle ABC with the sides 2 centimeter and another equilateral triangle X, Y, Z, but here length of sides is 4 centimeter. Now if you keep a ABC triangle on this or XYZ triangle on this, then they won't match in what size. In shape they are equal, but in size this is smaller one, this is a bigger one. They are not coinciding each other. Okay, so these two figures not coincide. And if you take a triangle, one triangle and a circle, whether they coincide each other, they won't coincide, because they are different in shape and size. Okay, so if two things coincide each other, then what we can say about that two things, they are equal to one another. Here these two things coincide each other, so we can say these two triangles are equal to one another. But here these two triangles are not coinciding, so they are not equal. And here triangle and circle, if you keep one shape on another, then they won't match exactly in shape and size, so they are not coinciding figures. Okay, so this is about which one? Fourth axiom. Next, fifth one, the whole is greater than the part. The whole is greater than the part. To explain that, I'll take one line segment AB, okay, and I'll take one point on AB, that is point P at 2 centimeter distance from A, okay, and this one is of length 8 centimeter, PB of length 8 centimeter. So now total AB is of length how much? AB is of length 10 centimeter. Okay. Now whole means whole straight line, full straight line length is how much? That is 10, right? And now you take the part of that line, that is 2 centimeter. Now 2 centimeter is bigger or 10 centimeter is bigger? 10 is bigger than 2, right? So similarly, suppose you take a whole line segment that is of length 10 centimeter and part of that another part that is 8 centimeter, then which is bigger? 10 is bigger, right? So this side what you have? This side you have whole and this side what you have? You have part. So whole is always greater than the part. Okay, whole straight line is of length 10 centimeter, that is greater than this part 2 centimeter as well as greater than the part 8 centimeter also. Okay, so that is about fifth axiom. Whole is greater than the part. And sixth one. What is a sixth axiom? Things which are double of the same thing are equal to one another. Now we take two things which are double of the same thing. Then what we can say about that things? Okay, we can say that two things are equal to one another. Now I'll take one line segment XY which is of length 2 centimeter. Now you take a line segment AB which is double of this line segment. Okay, so now draw one line segment AB. This is a rough figure, not exact figure, just to explain that sixth axiom. Now what we taken here? Line segment AB which is a double of XY length. Okay, so double of XY length means AB is of length 4 centimeter. Now you take one more line segment which is also double of this line segment XY, and I'll take that as a CD. How much CD is we taken this line segment which is double of this line segment XY, and this is 2 centimeter. Double means double of that means 4 centimeter. So CD is also 4 centimeter. Now what you can see, AB and CD, they are equal, right? AB is also 4 centimeter and CD is also 4 centimeter. So this is about a sixth axiom, that is if you take two things which are double, here are two things we taken are two line segments AB and CD, they are double of the same line segment XY. So what you can say about these two things? They are equal to one another. So things which are double of the same thing, then the things are equal to one another. That is the sixth axiom. And seventh one. Seventh, things which are halves of the same thing are equal to one another. Now I'll take one line segment XY, okay, of length 10 centimeter. XY line segment is of length 10 centimeter. Now I'll take half of this one line segment I'll draw which is half of this line segment. Okay, I'll take that line segment as AB. AB is a half of line segment XY, means what is AB length? AB length is 5 centimeter. Now take one more line segment which is also half of this line segment. Okay, I'll take that line segment as a CD. How CD is CD is also half of this line segment XY. Okay, then what is a CD length? CD length is also 5 centimeter. So now what you can say about these two line segments? They are equal to one another, that you can see clearly. Okay, what we taken here? We taken two line segments AB and CD which are half of the same line segment XY of length 10 centimeter. So then these two line segments are equal to one another. Okay, so that is the what seventh axiom. Okay, thank you.